And we have liftoff off of Mars Global Surveyor as America begins its journey back to the red planet.
There's a weird structure on Mars, a square. A near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened, and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then, the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, People freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, hey, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock. Have we found another civilization? Is that a door to someone's home on another planet? Can we peek through the windows? After all, it was NASA's Curiosity rover that sent this image to Earth, and right now, this rover is exploring the surface of Mars. Unfortunately, astronomers were fast to disappoint us. They claimed that it was just a natural part of the Martian landscape. There are several clues that made them think it wasn't a real door. For example, it's tiny, a mere 3 feet high. But it might simply mean the Martians aren't that tall, you may object. But scientists keep insisting that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. The thing is, if you look at the rock attentively, you may notice strata, the layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more, and now you can see that they disappear inside the door. And look at this. See those cracks? Yeah, those. That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. Now, this theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago, and Martian winds haven't got rid of it yet. And winds on Mars can be exceptionally powerful. This planet is infamous for its intense dust storms. Sometimes they kick up so much dust that you can see it through a telescope on Earth. Such storms occur every year and cover continent-sized areas. They also last for weeks at a time. But besides these annual storms, there are even larger storms that happen much more rarely, but they're more powerful and way more intense. Those are called global dust storms because they encircle the entire planet. But even if you got caught in the most severe storm on Mars, it wouldn't be as terrible as you might think. The wind speed on the worst Martian storms reaches 60 miles an hour tops. Hurricane-force winds on our planet can be twice that speed. You should also keep in mind that the atmosphere on the red planet is 1% as dense as the atmosphere on Earth. That's why, if you decided to fly a kite on Mars, you'd need the wind to be much faster than on Earth. Otherwise, you wouldn't even be able to get the kite in the air. In other words, even though it's quite windy on Mars, it doesn't feel as intense as on our home planet. Oh, by the way, you might have noticed I keep calling Mars the red planet. Why? Look, our neighbor is covered in dust, soil, and rock that is rich in iron oxide. That's what gives the surface of the planet its trademark red hue. And look, there's the trademark. Nah, just kidding. Mars is the fourth planet from the Sun. Not so far away from the star, you might say, and still, it's a cold and deserted world. The average temperature on its surface is minus 81 degrees Fahrenheit. But if you ever visit one of its poles during the wintertime, bring a lot of warm clothing, because the temperatures are likely to drop to minus 220 degrees there. In the summer, though, you might feel very comfortable in some regions. There, the temperatures can rise to 70 degrees, not very different from what we're used to. Mars is one of the most explored space bodies in the solar system. At the moment, NASA has 2 rovers roaming the red landscapes, Curiosity and Perseverance. There's also one lander called InSight and helicopter Ingenuity, nicknamed Ginny. Perseverance is the most advanced and largest rover ever sent to another world. The journey to the red planet took 203 days, and Ginny traveled to Mars attached to the belly of Perseverance. Sounds cozy. And now, I'm going to tell you something really curious. Let's say you're a Babylonian who lived around 5,000 years ago. Babylonia was an empire in ancient Mesopotamia. Just think back to 6th grade. Anyway, your neighbor comes up to you and says, "What day is it today?" And what do you answer? "It's Mars Day." Wait, what? When the ancient Babylonians created the week, they decided to divide it into 7 parts. Each day got named after some space body, like the Moon, the Sun, Venus, and so on. Mars Day was on Tuesday. The Babylonians believed that each of these space objects influenced their lives on the day named after it. And since Mars was red in color, they associated it with aggression. That's why on Tuesdays, they had special ceremonies to avoid the influence of the unfriendly planet. Indeed, Mars might seem unfriendly to a tired traveler. Its atmosphere is very thin. Its volume is a near 1% of the atmosphere on Earth. In other words, there's 99% less air to breathe on the red planet. Mars's atmosphere is mostly made up of carbon dioxide, At such high concentrations, it's toxic for us humans. And if you were looking for some oxygen to breathe on Mars, you'd come away empty-handed. There's only 0.1% of oxygen in the air on the red planet. That's definitely not enough for you to survive there. At the moment, Mars has 2 moons, Deimos and Phobos. Astronomers think they may be asteroids once caught in the gravitational field of the planet. The moons are shaped like potatoes. That's because their mass is too little for gravity to give them a spherical form. Potatoes, eh? Maybe they should be renamed mashed and au gratin. One day, Mars will get a ring of its own. It might happen in the next 20 to 40 million years. Will Brightside be there? Stay tuned. Mars's gravitational forces will tear apart the planet's largest moon, Phobos. Hey, it really will get mashed. Some chunks of the former moon will crash into Mars, and others will break apart and create the ring around the planet. This ring might exist for at least 100 million years. The surface of Mars is cut by a huge canyon system known as Valles Marineris. Sounds like a pasta sauce. If it were on Earth, it'd stretch all the way from New York to California, over 3,000 miles. At its widest part, the largest canyon on Mars is 200 miles, and it reaches 4 miles at its deepest point. If you still have difficulties imagining the sheer size of this natural phenomenon, here you go. Valles Marineris is 10 times the size of the Grand Canyon on Earth. Now, since we're on the subject of gigantic things, let's talk about Olympus Mons. This is the largest volcano in the solar system, and it's on Mars too. It's 3 times as tall as Mount Everest on our planet, and that's the tallest mountain above sea level. And the base of Olympus Mons is as large as the state of New Mexico. Now, scientists think there could have been water on Mars in the past. What made them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet, but Mars's atmosphere is too thin for this water to stay in its liquid form on the surface. Now, it only exists in the form of water ice. You can find it just under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes, salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. So, as a vacation spot, I think I'll pass.
You and your camera have been literally everywhere on Earth, on top of Mount Everest and at the bottom of the Mariana Trench. You've seen the Nile River, Niagara Falls, the Sahara Desert, the Grand Canyon, and a million other beautiful places. On every trip, you brought back breathtaking pictures. Your album is already as thick as an encyclopedia, and it's time to discover a whole new world of tourism. Let's head on a voyage to Mars. You're sitting in a shiny modern rocket, counting down for takeoff. It might seem like a big deal, but with modern technology, it's practically a ride on a bus. In only a couple of hours, you're on the surface. It's time to head to the first destination for any tourist on Mars, Olympus Mons. It's the size of the entire state of Arizona and is 16 miles high. That's 3 times the size of Mount Everest. And it's the highest mountain in our entire solar system. It's actually even more than a mountain. It's a giant volcano. This entire mountain was formed when streams of lava rose to the surface, flowed down the volcano's slopes, and slowly cooled. The freshest soil layers are about 2 million years old. So scientists don't rule out the possibility that this volcano will wake up one day. Hopefully, you're not close by when it erupts. And there are statues of Greek deities everywhere. There's Apollo, and there are Athena and Artemis, and here's Zeus and Neptune. In the myths, these deities lived on Mount Olympus in Greece. These aren't natural, of course. We built these monuments to attract more tourists. There are even plenty of souvenir stalls where you can buy a lightning t-shirt in honor of Zeus. You take your first picture on Mars and move on to the next exciting place. This is a complex of 12 giant volcanoes. Some of them reach almost the height of Olympus. It's like if you piled 60 Empire State Buildings on top of each other. They're so tall because gravity is much weaker on Mars than on Earth. There isn't as much force pushing down on them, so they can grow much bigger than anything you could find on Earth. You feel lighter than you've ever felt before, and you can lift objects 3 times as heavy as you could back home. It's easy to see why the volcanoes are so big when you jump and fly 9 feet into the air. These volcanoes have been erupting for almost 2 billion years. That's almost half the age of our home planet. That's another reason they've gotten so tall. Click! The photo is ready, and you get on the rover to explore the next landmark, Valles Marineris. This is the largest canyon in the world. It's longer than the distance from New York to Miami, and it's 4 times bigger than the Grand Canyon here on Earth. We don't know exactly how it came to be, but the most popular theory suggests that it was all because of the lava, which pushed the crust upward as it moved underground. Over time, these valleys grew into the enormous canyon of Valles Marineris. The next stop is Cydonia. The cool thing about this place is the giant rock with a human face. In 1976, we saw photos from the surface of Mars and could clearly recognize a human head here. People immediately came up with 1,000 theories as to how it could have appeared here. The fun theorizing and speculation came to an end, though, when new photos were taken in 2011. These clearer pictures showed that the eyes, nose, and mouth were just shadows that couldn't be picked out in the original low-quality image. In fact, it's just a hill, a lot less exciting up close. Wear a warm jacket to view the next landmark spot. This is the North Pole. Make sure you keep a tight hold of your camera too. It's pretty windy out here. That ice that you see is carbon dioxide, which looks like that because of the extremely low temperatures. It can get cold here at negative 226 degrees Fahrenheit. This cold place and the North Pole are responsible for the strong winds all over the planet. And there are even geysers at the South Pole. In spring, when it gets warmer, jets of carbon dioxide rush to the surface, taking dust and sand with them. Quick, get it on your camera! Various studies say that there is an underground lake as wide as Delaware Bay, 1 mile beneath a thick layer of ice. Moving on to Gale Crater. This is where the Curiosity rover landed in 2012. Oh, and here's its replica. This little guy has been studying the surface of Mars for years and has found signs of evaporated water. This means that Mars could have fostered life in the past. The rover also found a lot of evidence of organic molecules, as well as methane gas. It could come from microbes and other living things, but we don't know enough yet to say for sure. The existence of life on Mars hasn't been confirmed, but it's exciting to think that there could have been real Martians alive at some point. You take a selfie, like you're holding Curiosity on your arm. Great, the Mars cab is already here for you, and you're heading toward Medusae Fossae. Many people believe that this could be an alien crash site because of the strange appearance of these rocks. Of course, that's not true. Scientists suggest that volcanoes have been erupting here for years. Lava has cooled into rocks, and strong winds have given them strange shapes. This entire volcanic deposit covers an area the size of 1/5 of the United States. And here's a place that has made Earth scientists nervous and even scared. Gale Crater and these lines on the slopes. Studies have shown that this place was moistening, meaning that water could flow there. But then it was determined that it was dry sand streams. Scientists fear this place may be home to alien microbes, so you probably shouldn't get too close. Another mysterious place for tourists on Mars is ghost dunes. In the ancient times of this planet, there were dunes dozens of feet high. But then, they were flooded by water or lava. Their bases are preserved, but the tops have been erased. The covered areas of these dunes can still harbor microbes. Here, they are protected from wind and solar radiation and may still be preserved. Contact with them can be dangerous for humans, so you take a photo from afar. The next spot is on Mars's satellite, Phobos. Oh, there's a pretty big crowd of people gathered here. And then you see it. Phobos monolith. It's a massive rock as tall as a 30-story building. We learned about this object from pictures taken back on Earth. The monolith casts a great shadow and has spawned many theories. For example, some claim that it was built by an ancient civilization or was left here by aliens. It might even have been a beacon. All these people came here to test the theory for themselves, but it just looks like a rock up close. One more photo, and you have to hurry to the bus that will take you to Jupiter's satellite, Io. It's only safe to be here in special capsule cars that fly over the surface. And when you see volcanoes constantly erupting, you understand why. Jupiter's gravity compresses the insides of Io. They heat up and rise to the surface, erupting in volcanoes on its surface. They eject so much material that Io completely changes its surface every few millennia. Now we turn on the hyperdrives and head out into deep space. Here, in complete darkness, is the Voyager probe. It was launched in 1977 and is still in operation. It's the first human-made object to leave our solar system's borders and is the world's most distant spacecraft. Voyager carries a golden disk with a message for extraterrestrial civilizations. This amazing disk contains pictures of Earth's landscapes, people, animals, and various sounds and music. Unfortunately, it will take many thousands of years to reach the nearest star system, so we're not very likely to hear back from any aliens anytime soon. You take selfies and move on to the next part of the tour. Here, 1,000 light years from Earth, is a black hole, the most mysterious and heaviest object in the universe. It weighs as much as the sun, but it's much smaller. It's so heavy that it attracts absolutely everything, even light. So the black hole isn't actually black. It has no color at all. You can only observe it from a very great distance because it bends time. The closer you are to it, the slower time will go. And if you want to fly just a second closer to it, weeks or even months might pass on Earth in that time. In the old tradition, you toss a coin into the black hole and continue your journey through the distant cosmos. On the way home, you have to stop by an iconic spot on the moon. Here in the Sea of Tranquility, there's an entire park near the landing site of Apollo 11. This is where the first humans set foot on the surface of the moon. Neil Armstrong's first boot print is still there on the surface as proof. It was made in 1969, but even now, it looks exactly the same. Something is happening on the red planet! Scientists believed that they knew nearly everything about its atmosphere, but a NASA rover has discovered something unexpected. There's more oxygen on Mars than they thought, and it behaves in weird ways. In the spring and summer, oxygen levels go up even more, and no one knows why. Now, you might think that when there's oxygen in an atmosphere, it's mostly because there's life somewhere around, like trees on Earth that produce oxygen through photosynthesis. But on Mars, it's not that simple. Non-living processes can also create oxygen, so we can't surely say that its presence means there's life on Mars. Mars has long been one of the main candidates when it comes to looking for signs of extraterrestrial life. Back in the 90s, scientists announced they had spotted potential proof there could be life on Mars because of microbes they had found in a meteorite that had arrived from the red planet. It looked like they had found fossils of bacteria. They actually stumbled upon tiny crystals of magnetite in the meteorite, which they believed could only have been produced by living organisms. It was such a mind-boggling discovery. People were excited, but many were also skeptical. It didn't prove there really was life on the red planet. Maybe there was life there a long time ago. The meteorite is thought to have originally formed on Mars billions of years ago, and to have landed on Earth thousands of years ago. Skeptics soon started to pick apart the evidence and eventually found some things that didn't make sense. For example, these magnetite crystals. No one could be sure how they formed. Why do they have to be bacteria? Some research has shown they could be the result of shock waves. Recently, The Perseverance rover has collected a couple of new rock samples from the Jezero crater on Mars. The theory says that about 3 billion years ago, before the red planet lost most of its atmosphere and basically just dried out, there was a big lake with a river flowing from it in that area. Whoa, what a great environment for life! Perseverance studied mud samples it had found on the bottom of the evaporated saltwater lake. Scientists were amazed to see a record number of sulfate molecules, something we usually find in mollusk shells on our home planet. Such organisms evolved a couple of 100 million years ago, but maybe there was a time when some of their space ancestors lived in water bodies on Mars. Mars has weaker gravity than Earth, which means these weird species could have got really big there, way bigger than their Earth cousins. Gravity plays a significant role when it comes to limiting the size of organisms. Bigger organisms need more energy to move against gravitational forces, but the creatures that may have lived there long ago are just a mix of hypothesis and our imagination, something that's still really hard to prove. Meet the Curiosity rover, another robot NASA is using to explore Mars. Curiosity has been in charge of measuring the composition of the atmosphere of the red planet for many years now. The rover has discovered that it mostly consists of carbon dioxide and a little bit of nitrogen and argon. The atmosphere of Mars has only 0.1% of oxygen, since, as far as we know at the moment, Mars doesn't have plants that could produce enough oxygen. But Curiosity has also discovered anomalies no one can really explain. It's found out that there are spikes in oxygen levels in the Gale crater during the Martian spring and summer. Every year, oxygen levels go up and down in unpredictable patterns there. What's even more interesting is that the oxygen spike is similar to a seasonal spike in methane, which is a gas we often associate with life on Earth. No wonder scientists are scratching their heads and wondering if there's a connection between the two gases, and if they both come from the same source on the Martian surface. Is there something big that breathes there? Come on, we'll be happy even with some small space worms in the soil. There's a type of salt called perchlorates in the Martian soil. Some scientists believe perchlorates might be responsible for the strange spikes in oxygen levels. But like with most things we know about space, it's just a theory. Also, scientists think that perchlorates breaking down in the Martian soil release oxygen too slowly to cause and explain the sudden increase in oxygen levels. One of the suspects is hydrogen peroxide, which is like water's unstable cousin. Hydrogen peroxide forms when sunlight breaks up carbon dioxide and water vapor in the Martian atmosphere. It can seep into the soil and stick to particles underground, which means it forms some kind of oxygen storage tank. Some data even show there are pockets of subsurface water in the Martian soil that may be hiding enough dissolved oxygen to actually support life. But even if the hydrogen peroxide could stay in the soil for millions of years, it would still only explain a small part of the increase in the level of oxygen. So you can't blame it for the whole thing. We can also take a look at an old experiment from the 1970s, where scientists found that moistening the Martian soil caused it to release a lot of oxygen. However, they did this experiment at a warmer temperature than the planet's average. And again, it doesn't explain how the oxygen spike keeps happening every year. None of the clues we have seems to fit the case. Mars may not have enough of its own oxygen, but it's possible to make this gas there. NASA conducted a small experiment where they tried and managed to produce oxygen on Mars. MOXIE is a device that can make oxygen on Mars. It managed to produce enough oxygen for an astronaut to breathe for 100 minutes. This awesome device worked in pretty tough conditions, at night or during the day, at extreme temperatures, and during the crazy dust storms the red planet is known for. Despite all this, MOXIE still kept up with producing high-purity oxygen. MOXIE is a clever device that can make oxygen on Mars by taking in carbon dioxide from the planet's atmosphere and heating it up to incredibly high temperatures. This allows the device to pull oxygen atoms from the carbon dioxide and produce breathable oxygen gas. If we want to use MOXIE to make enough oxygen for human missions to Mars, we need to make a bigger version of the device. But if we make it bigger, we might have trouble keeping it at the right temperature and making sure it heats up evenly without breaking. The ultimate goal would be to create an oxygen device that could continuously support a human mission for about 400 days. With a bigger version of MOXIE, we'd have enough oxygen to support crew members and even propel a return rocket to our home planet. When you see the dusty red surface of Mars, you can't say it's a place that hides liquid water underneath. Some say it's too cold for water to exist on Mars anyway. But there are stories that there could be a hidden world of liquid water, just like subglacial lakes in Antarctica. And to find out more, we might have to drill down about a mile beneath the surface. Unfortunately, it's not going to happen anytime soon. But in the meantime, scientists have been using a spacecraft called Mars Express to study radar reflections around the southern pole of Mars. The reflections seem to indicate there could be liquid water, and the planet's interior might be keeping it warm. But some claim it might just be rock. We hope there are underground lakes on Mars because it would be a perfect spot to look for life. After all, scientists have found bacteria living in subglacial lakes on Earth. But we don't know for sure how deep they are, or if they're just small veins of water in the ice. Only time and more exploration will tell.
It looks like a regular beach, but something sets off an alarm blaring in your head. The sand looks too red, the sun is too bright, the wind is all wrong, it's hard to breathe, and there's no water in the ocean. Well, panic not. It's normal, since you're on Mars. For the longest time, we've seen Mars as a dry, lifeless dust ball, a freezing desert where water exists only as ice or vapor. But new research suggests that billions of years ago, it was a totally different place. And instead of endless dust, it may have had something much more familiar to us: sunny, sandy beaches. Scientists from Penn State, UC Berkeley, and Guangzhou University studied radar data from China's Zhurong rover. It started to roll across Mars in 2021. While exploring the surface of the red planet, it found sloping rock formations that looked strikingly similar to the ones found on Earth's coastlines. Those are called foreshore deposits. They form when waves push sand onto a shoreline. But Zhurong wasn't just taking pretty pictures. It also had ground-penetrating radar, a tool that allowed it to scan deep below the Martian surface as it traveled 1.2 miles between May 2021 and May 2022. And it found something pretty wild: layers of sediment sloping down at a 15-degree angle. This pattern is identical to the ones left behind by waves on Earth. And this wasn't from the wind, volcanoes, or anything else. It just looked like a real beach. And that's actually a big deal. Because if there were waves and tides, there must have been a large body of water. That means Mars may have once had just the right conditions for hosting life. Even after 3.5 billion years, the formations are still incredibly similar to beaches on Earth. So there must have been a time when Mars was much more than just a dusty rock in space. After revealing this shocking news, Zhurong's radar scanned 260 feet deep into the ground, discovering sediment layers. They once formed along a path perpendicular to an ancient shoreline, the one that likely existed 4 billion years ago. At the same time, it might not be all that surprising. Back then, Mars wasn't the dry, frozen wasteland we see today. It had a thicker atmosphere, a warmer climate, and plenty of liquid water. And I'm not even talking about some tiny puddle. Beaches don't form without a massive body of water. For wave to shape the land like this, there had to be rivers flowing into a vast ocean. Powerful currents had to be moving sand around, and water had to stick around for a long time. This couldn't be just a brief wet spell. It was a period where Mars was hydrologically active for millions of years, potentially being a place where life could have thrived. This discovery gives even more weight to one theory. It has been puzzling scientists since the 1970s. That's when NASA's Viking spacecraft snapped images of what looked like a shoreline wrapping around Mars's northern hemisphere. But there was a problem. The shoreline was all over the place, with elevations varying by up to 6 miles. Wow, which is nothing like our flat, mostly consistent shorelines we see on Earth. This difference made scientists doubt that a Martian ocean ever existed. For years, scientists had been trying to crack this mystery. In 2007, they suggested that Mars' rotation actually shifted billions of years ago. As the planet's massive Tharsis volcanic region grew, the planet's spin axis tilted, warping the surface. It could explain why the shoreline is so uneven today. In other words, what once was a flat and level landscape got distorted over time. Interestingly, Mars has been dropping hints about its watery past for years. Curiosity found ancient ripples in Gale crater. There were signs of a long-gone lake. Perseverance is currently studying a fossilized river delta in Jezero crater. Now, with Zhurong's evidence of an ancient ocean, it all comes together. Small lakes? Check. Rivers? Check. A massive ocean covering the northern lowlands? Quite possibly. Zhurong's mission wrapped up in May 2022 after dust blocked its solar panels. But future missions could still explore those ancient shoreline deposits. Scientists might send new missions to drill deeper into the ground to retrieve samples. Or we could use better radar to map Mars' subsurface in more detail. There's a real hope to excavate those areas in the future and find even more clues about Mars' past. At the same time, NASA's Perseverance rover is already working hard in Jezero crater collecting samples. Scientists hope that it will bring them back to Earth in the 2030s. While those won't include samples from the ancient ocean, they could still help us find out more about Mars's wetter history. For now, the discovery of ancient beaches on Mars gives us a peek into a time when the planet might have looked a lot more like Earth, with water, waves, and rivers. Now let's speak about the Perseverance rover that's still working on Mars in more detail. It has a special drill on its arm and uses it to scrape off the dust and top layers of rock, making small 2-inch wide circles in Jezero crater. Once, one of its cameras took a close-up photo, and the image showed that the rock wasn't smooth. It was made of tiny interlocking crystals. The rover used 2 special tools to analyze the rock's chemistry. The results confirmed that the rock, named Rochette, was volcanic. It meant it formed from lava or magma, not from mud and clay, like scientists had expected from a former lakebed. Perseverance, also known as Percy, landed on Mars in February 2021, along with a small helicopter named Ingenuity. It is the most advanced rover ever sent to Mars, following in the footsteps of Curiosity, Spirit, Opportunity, and others. But Percy has a different mission. While older rovers mainly studied Martian rocks and climate, Perseverance is searching for signs of past life. Scientists chose Jezero crater because it looks like it used to be a lake where tiny life forms could have lived. The rover drills, scrapes, and collects rock samples to study with its science tools. It also saves some samples to bring back to Earth in the future for even closer study. Perseverance has found some surprising things on Mars. Scientists studying the data it sent back have discovered that Jezero crater has changed a lot over time. Long ago, this area had flowing lava, a lake that lasted for thousands of years, rivers that carried mud and sand, and even massive floods that brought in rocks from far away. It means that Jezero's history is more active and unpredictable than scientists expected. This definitely made it harder to find the sedimentary rocks they were looking for. But it has also revealed new places where ancient life might have existed. Another exciting discovery is that every rock Perseverance has studied so far contains carbon-based materials, the same stuff that life on Earth is built from. NASA's Perseverance rover also carries a special tool called MOXIE, which has managed to make oxygen from the carbon dioxide in Mars' atmosphere for the first time. Over 16 test runs, MOXIE produced about 4 ounces of oxygen. That's enough to keep an astronaut breathing for about 4 hours. It worked even better than expected, making up to 0.42 ounces of oxygen per hour. After running successfully for 2 years, MOXIE completed its final test in September 2023. It brings us one step closer to sending humans to Mars in the future. In any case, back to the discovery of ancient shorelines on Mars. This finding might help us see the red planet with new eyes. Water might have been flowing across its surface for tens of millions of years, carving out lakes, rivers, and even a vast ocean. What else have we misunderstood? Did Martian dinos stroll across the vast green valleys of the planet? Or were those bizarre marine creatures the likes of which we can't even imagine? Well, we don't know yet, but one thing is very likely. Mars had an era of warmth, water, and maybe life.
Mars can be secretly messing up the depths of our oceans. The red planet is 140 million miles away from Earth, so we once thought that it couldn't have much of an impact on us. But that changed recently with the discovery of some kind of butterfly effect. What starts with a small gravitational pull in space ends up creating giant whirlpools down here. This suspicion began when scientists decided to explore almost 300 deep holes drilled in the ocean floor, which were made back in the 60s. Their goal was to understand the strength of deep ocean currents by analyzing sediments. Materials like sand or mud that accumulated at the bottom of the ocean over the last 65 million years. The bottom of the ocean has layers upon layers of sediments. When these layers show a continuous pattern, it means that the materials have been gradually layering over time without any sudden interruptions. In other words, deep currents were calm and stable. But the researchers also noticed a strange pattern. During specific time periods, they couldn't find any records of sedimentation, which means that something else was interrupting this process. The most likely reason for these gaps was the presence of intense currents at the bottom of the sea. Because they were so strong, they probably moved sediments from their original spots. But here's the weird part. All the gaps identified in the study occurred at intervals of exactly 2.4 million years. The data showed a total of 27 gaps. That can't just be a coincidence. So the scientists realized they were not checking simple breaks in the sedimentation process, they were analyzing the presence of cycles. According to experts, the only plausible explanation for them lies in space and is probably the result of something known as the astronomical grand cycles. To understand this process, we first need to mention the Milankovitch cycles. They're named after the Serbian scientist who suggested a century ago that changes in the way Earth moves around the Sun and tilts on its axis can affect Earth's long-term climate. The thing is, the movements of Earth can be affected by many things, including other planets. Normally, our planet's orbit around the Sun isn't a perfect circle, but it's pretty close. However, from time to time, this path is directly affected by the gravitational pull of Jupiter and Saturn. So it's kind of like these two giant planets can pull our orbit, causing it to become more elliptical. Variations like this can affect the amount and distribution of sunlight, changing the climate here on Earth. According to the Milankovitch theory, Earth's climate patterns change in cycles of 405,000 years, 100,000 years, 41,000 years, and 23,000 years. And the theory is that these cycles might trigger the beginning and the end of glaciation periods, also known as ice ages. His theories were actually confirmed in the 70s by scientists who were also looking for evidence of these cycles in ocean floor sediments. Recent calculations have shown that besides the Milankovitch cycles, there are climate changes that follow much slower rhythms. They don't change every tens of thousands of years. Nope. We're talking about periods that stretch out over millions of years. And this is exactly what the astronomical grand cycles that I mentioned earlier are about. We know about such events basically because of evidence based on mathematics and computer modeling. But it is really hard to find any geological proof of the existence of these million-year astrological cycles, or any clue of how they affect Earth. That is, until now. Turns out, what scientists found at the bottom of the ocean could be just the proof we needed. And that's because the 2.4 million period lines up exactly with records of interactions between Earth and Mars. As the two planets chart their orbital paths, their gravitational fields interact in a process known as resonance. Yep, exactly like what happens with Jupiter and Saturn. From time to time, the gravitational forces of the red planet pull our orbit a bit closer to the Sun. And just like the shorter Milankovitch cycles, this grand cycle also affects our climate. In this case, by increasing the solar radiation that reaches Earth, making our planet warmer. To be honest, experts believe that this amount of extra solar radiation that Mars can somehow give us is not that big of a deal. I mean, it's not going to make our planet so hot that it will make us feel like we're stepping onto the sun. But this slight difference in climate can be enough to change some behaviors on Earth, such as ocean currents. Warmer climates tend to produce more frequent major storms, and that often produces sediment-stirring eddies, also described as giant whirlpools, which can reach the seafloor at the deepest parts of the ocean, known as the abyss. Finding those gaps in the deep ocean sediment record is really impressive because it's probably the strongest evidence we have of the astronomical grand cycles. As I mentioned at the beginning of the video, it's all like the butterfly effect. Every 2.4 million years, Mars's gravitational pull shifts Earth's path around the Sun, causing our climate to warm up. And when the planet is warmer, it can lead to the formation of large whirlpools, which end up turning the deep ocean waters upside down. And there's one more thing. The cycles found in the research also line up with already known periods of warmer climate throughout world history, like the famous Paleocene-Eocene thermal maximum. This event took place around 56 million years ago, when Earth was warmed by about 14 degrees Fahrenheit. Loads of theories have popped up trying to figure this out, like a glitch in Earth's orbit or maybe the passage of a comet. But with this new study, it looks like Mars could also be involved in this event. These new findings are pretty convincing and exciting, sure, but scientists still need to do more work to link these possible cycles of climate change with deep-sea currents. I mean, they did a good job of finding an explanation for the sediment gaps, but so far, it's just a suggestion. Their success is really important for the whole scientific community, though. After all, knowing when exactly these astronomical grand cycles happen and how they affect Earth can help us a lot. Especially to differentiate when climate change happens due to a natural event and when it occurs due to human intervention. Studying these whirlpools can also provide scientists with crucial insight into how climate change affects ocean circulation. So, another reason why this finding is so crucial has to do with the potential collapse of the Atlantic meridional overturning circulation. In short, this is a system of ocean currents that circulates water within the Atlantic Ocean, being responsible for bringing warm water north and cold water south. This is what brings warmth to different parts of the globe and also carries nutrients necessary to sustain ocean life. However, there are some fears that this system might stop or become too slow anytime soon. If that happens, oxygen-rich surface waters would no longer mix with deeper waters. But the good thing is that this possible link between Mars and Earth gives a positive take on this situation by suggesting that in a warmer world, more intense deep ocean currents may prevent our seas from stagnating. But again, it's just a suggestion. The evidence is still thin. Some skeptical experts like to point out that although eddies have indeed become more active over the past few decades, satellite observations have shown that their currents aren't always able to reach the seafloor and maintain an effective water circulation. For now, all we know is that it's hard to say who is right. Only the following studies will tell.
Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now, curiosity stumbled upon something interesting in the Gale crater, a vast basin on the Martian surface where, billions of years ago, water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate. There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time, show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and is capable of heating Martian rock samples to extreme temperatures. There are 2 ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced 2 possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hoped. Well, at least not on the surface. That doesn't mean underground life couldn't exist though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars. You know, Mars quakes. And it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet, and it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas, and they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. That would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor. And this could help us avoid similar mistakes in the future. NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements, and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, So that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while cacao is metallic-looking and dark gray. It's rounded and smooth too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space, so Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?
Of all the creatures on our home planet, this could be the only animal that could survive harsh conditions on Mars. The tardigrade. These fellas have another name because of their unusual looks: water bears or moss piglets. They live literally everywhere across the globe, from coastal dunes to mountains, from the lush Amazon rainforests to the barren landscapes of Antarctica. Some live on land, but tardigrades are creatures that need water around their bodies to enable gas exchange and generally stay hydrated. That's why they prefer soil, moss, or leaves covered with a layer of water. And since they're aquatic creatures, they usually choose freshwater bodies like lakes, rivers, and ponds. You haven't come across these cool animals before because they're only 0.02 inches long. You can barely perceive them with the unaided eye. But since they're virtually immortal, we can assume they've developed some amazing survival tactics. If we loaded them in a tiny spaceship and sent them to Mars, they'd be a little shocked at first, especially because of the temperature. Sure, they can live through a wide range, even going below minus 458 degrees Fahrenheit and up to 302 degrees Fahrenheit. And Mars might seem like a very hot planet when you see it in pictures, but the temperatures there are actually low, way lower than on Earth. I mean, it's farther from the sun and has a thin atmosphere, so temperatures there can drop to minus 200 degrees Fahrenheit or go up to 70 degrees Fahrenheit. On Earth, the lowest temperature was recorded in Antarctica. It was minus 128.6 degrees Fahrenheit, while the highest occurred in California, 134 degrees Fahrenheit. Tardigrades are also pretty resilient when it comes to strong pressure. They can take one that's 6 times bigger than the pressure at the bottom of the ocean. Now, for every 33 feet you go down below the surface, the pressure doubles. So, at a depth of 2.4 miles, the pressure is 380 times greater than at the surface. And in the very deepest parts of the ocean, it can be 1,100 times greater. The pressure on the red planet is about 6 times stronger than in the ocean depths. So I guess it's a little bit too much. It would be hard for these little creatures to adjust to such conditions. They would have to evolve through the next few generations to become even more resilient so that they could enjoy their time on Mars more. The food could be one of their main problems though. Some tardigrades mostly eat plants like moss, algae, or some flowering ones, and they like them served with a portion of bacteria. Others are carnivores that eat smaller tardigrades or other microscopic organisms. Well, they'd find nothing like this on Mars. So I guess we'd have to fill their tiny spaceships with lots of stashes of food they would be able to pull inside their tubular mouths. Now we're getting to the really tricky part: water. The red planet is a dry and dusty desert today. But come on, look at all those riverbanks and dried up deltas. Water must have flowed on its surface a long time ago. It's hard to understand where it all went, but it's highly possible most of the ancient water ended up trapped within minerals on the planet's crust. Some older research suggested that most of this water had escaped into space when the sun's radiation had ruined the atmosphere of Mars. But a new study has shown that only a little bit of water escaped, while most of it is still there, hidden and waiting for us to discover it. Also, a few years ago, researchers found signs of hydrated minerals on the slopes of the red planet, where they saw mysterious darkish streaks that seemed to flow. It mostly happens during warm seasons, since they fade when it gets cooler. These downhill flows could be evidence of real liquid water on Mars. Scientists have discovered some minerals that confirm this idea too. These minerals can lower the freezing point of water like salt does on icy roads. That's why scientists think there might be a shallow underground flow of briny water that causes these streaks. Tardigrades probably have excellent instincts, considering they can survive even in the toughest conditions, so they'd probably find water on Mars way before us. But even if they didn't do it right away, they would still have their tactics to stay alive for a while. If this creature loses 99% of its water content, it can survive by pausing most of its vital functions. It can remain in such a state for a couple of years. Tardigrades can absorb extremely strong impacts that would easily crush other animals, including us. They can withstand radiation levels so high that they could destroy a human. And even if we do send tardigrades to Mars one day, that won't be their first trip to space. In 2019, a spacecraft went to the moon, carrying thousands of tardigrades, the first lunar library, human DNA samples, and a DVD-sized archive that contained 30 million pages of information. The idea was to create archives of all the knowledge the human race had collected. But seconds before the spacecraft had to land, the mission control lost contact with it, and it crashed into the surface of the moon. The team was wondering what was going to happen with the spacecraft's cargo. After lots of discussion and analysis, they assumed that the library had survived, and even crazier, perhaps tardigrades had too. They were in this dehydrated kind of dormant state, so they shriveled up into tiny balls. They lowered their metabolism and expelled most of the water from their bodies, waiting for a better environment where they could be their best selves once again. These creatures can stay like this for decades and survive extremely harsh conditions. And this wasn't the first organized tour to space for tardigrades. In 2007, a team of scientists sent a group of these tiny water bears to orbit our home planet on the outside of a rocket for 10 days. They did pretty well, considering that when the rocket got back to Earth, 68% of these creatures were alive. Scientists don't put all their hopes only on these water bears. They keep testing if there are some other life forms that could survive on the red planet. They did an experiment called biomechs on the International Space Station. They took tiny organisms such as algae, bacteria, and other similar creatures and kept exposing them to really tough conditions in space for 18 months. This means things like huge changes in temperature, extreme radiation, and vacuum. The amazing part is that many of these tiny life forms survived these harsh conditions and came back to Earth as true space heroes. So they could probably deal with the hardships of living on Mars. Scientists studied archaea as well. Those are tiny ancient microorganisms that have existed in salty seawater on our planet for more than 3.5 billion years. Some of their relatives from the Arctic also survived in space-like conditions. But life on Mars doesn't have to be a whole new thing. Billions of years ago, the red planet might have been a bit like Earth. It most likely had water, and that's one of the key ingredients for life. Scientists believe tiny organisms called methanogens might have thrived there. They were hiding beneath the surface to stay safe from harsh radiation. These organisms could have breathed in hydrogen and carbon dioxide, exhaling methane gas. But as they gobbled up hydrogen, which was a powerful greenhouse gas back then, they might have cooled the planet too much. So it's possible these ancient microbes are still somewhere there, trapped in ice deep below the surface. They could be in a sort of deep sleep, waiting for better conditions to wake up, or some new cool friends from Earth.
Uh-oh. Something is nearing the surface of the planet. It looks like a fireball, hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. Yeah, I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. Hall is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But, according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the red planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these two collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are three kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh. Hundreds of spaceships take off from Earth's surface and head toward Mars. Fast forward 7 months, and this space fleet of ships is near the Red Planet. Soon they will all land, and a few thousand people will become citizens of Mars. Perhaps they will never return to their home planet, because there will be absolutely all conditions for a comfortable life here. It takes time and many expeditions to create a self-sustaining colony on Mars. Here is how, step by step, people might build a full-fledged city there, with factories, hospitals, apartment buildings, and even clubs and restaurants. First, we need to pick a time to launch the rocket. a launch window opens once every 780 days. That's when the distance between Earth and Mars is the shortest. In this case, the journey will take about 6 to 7 months. Let's move to the launch pad. Here we see the spacecraft connected to a booster rocket. Ignition! The booster sends the spacecraft into the air. It then undocks and lands back on Earth. At the same time, the spacecraft's engines start and it makes its way to Earth's parking orbit. To make this ascent, the ship has used almost all its fuel and now needs refueling. To do this, we use our booster again. A huge crane places another spacecraft on the booster. There are huge fuel tanks inside the ship. The booster launches from Earth and takes the refueler into orbit. It docks with the spaceship and fills it with fuel. The journey through space may need a total of 5 such refuelings. And for the first mission to build a colony on Mars, we need 5 spaceships. So that's about 25 launches from Earth. Considering that the booster costs $230 million, the refueler $130 million, and the ship itself is $200 million, the price tag on the mission is pretty impressive. So, ignition. Fast forward in time, and the first 5 ships descend to the surface of Mars. These ships haven't brought the first humans. They carry only payloads, like fuel and water supplies, oxygen for breathing, and medical supplies. There are also first living modules, waste management systems, and a huge number of solar panels for generating electricity. Before landing, one of the ships launches a system of satellites into orbit. It'll provide communication on the red planet. So, the robots begin their work on Mars. First, a whole bunch of little rovers line up and unfold solar panels. Their total area reaches the size of 7 soccer fields. They're much less efficient on Mars than on Earth. Frequent sandstorms fill the working surface of the panels with sand. But at the same time, the strong winds of the red planet also help to wipe the sand away. Other rovers, equipped with powerful drills, begin searching for water in the Martian soil. When they find water, people will begin producing fuel. We'll combine carbon dioxide from the atmosphere with the mined water at a high temperature and under high pressure. It'll result in getting methane for rockets and oxygen for breathing. Since February 2021, Mars Perseverance rover has been testing the technology for oxygen extraction. It has a box inside. This is the Mars Oxygen IRSU experiment, also called MOXIE. This thing pulls Martian air inside and then, under high pressure, takes 1 atom of oxygen from carbon dioxide. Such a thing, about the size of a shoebox, can provide enough oxygen for 1 astronaut to breathe. But if you build the same mechanism, but the size of a large factory, it'll produce oxygen for an entire colony and release the rest into the atmosphere of Mars. Another group of rovers is working to turn the surface of Mars into a landing zone to prepare for the next step in colonizing the red planet. By this time, the robotic population of Mars has been working on these tasks for 2 years and 2 months, and people on Earth have been waiting for a new flight window to open. This time, not 5, but 12 spaceships are coming to Mars. 10 of them are cargo ships, which bring construction materials, fuel, and other supplies, as well as a lot of scientific equipment and 3D printers. 2 other ships carry the first interplanetary astronauts. The doors of the spaceships open, and 30 heroes set foot on the surface of Mars for the first time in history. These people are scientists, engineers, and doctors. They have undergone a strict selection and long training to become the first people to conquer another planet. And these guys don't have a return ticket. They'll have to stay on Mars for 2 years. The astronauts live right in their spaceships and try to get used to the unusual conditions on Mars. The temperature here is about minus 80 degrees Fahrenheit. Also, the gravity on Mars is 2.5 times weaker than on our home planet. That means a person here can jump twice as high and lift heavier objects. But the muscles in human bodies have a hard time getting used to such a difference. So astronauts can't work full-time. The first thing they do is unload cargo ships and deploy life support systems. Some people are experimenting with turning Martian soil into material for 3D printers. Others are setting up greenhouses and cultivating soil to grow plants. The human waste recycling system the robots brought here is used to make fertilizer for plants. 2 more years and 2 months have passed. We see a launch of a spaceship, not from Earth, but from Mars. The 30 astronauts have completed their mission and are on their way home. It's easier for spaceships to take off from Mars because the gravitational force here is less powerful. At the same time, ships are launched from Earth. They'll bring nearly 100 new inhabitants and even more cargo to Mars. When this space fleet arrives at the red planet, the astronauts can taste the first food grown here. 3D printers begin building homes on Mars. They print outer shells from Martian soil and plant waste. These shells will protect the dwellings from solar radiation and strong winds. And inside the shells, people will build permanent houses. They're inflatable and are equipped with modules brought directly from the spaceships. These houses have living bays, research bays, and communication centers. The construction goes on for 2 more years until the next flight window opens again. Some astronauts leave Mars, but more and more people come here with every new mission. They no longer live in spaceships. There are comfortable underground houses and 3D printed shelters. Most of the food is already produced on Mars. A new generation of robots works together with farmers. Other robots help to build even more houses to accommodate the ever-increasing human population. 2 more years have passed. Various space agencies launch their missions to Mars. There are more people, more scientific equipment, and even tanks with fish. In 2035, Mars and Earth are at a record short distance, so people send a huge fleet of ships with astronauts and construction materials. By this time, the human colony looks like a small city with many interconnected domes. Its inhabitants have already begun building an underground network of tunnels to move between houses, laboratories, and factories. They've also built the first hospital. 2 years later, the population of Mars reaches the 1,500 mark. Almost all of these people will become permanent residents of the planet. 4 years and 2 more launch windows later, the first restaurant opens its doors. Also, the construction of a nuclear power plant begins. Once it's finished, the Martians will no longer need constant supplies from Earth. From above, the colony looks like a small town. There's a farming section where food is grown, a living section, and a factory district. And with each new mission, people bring more and more solar panels. Now their total area equals dozens of soccer fields. All this allows the astronauts to feel at home. They also don't have to wait for food supplies from Earth. 20 years of the human colony on Mars. Its population is now about 30,000 people. Workers begin to bring their families to Mars. The first schools are built here. 30 years. The population is already over 100,000 people. The colony's infrastructure allows it to be completely self-sufficient. People produce enough food, get enough fuel and oxygen. Around this time, the first plants start growing in Martian soil. There's more and more oxygen in the planet's atmosphere. The trees planted in greenhouses contributed to this. The greenhouse effect from all the human activity helps warm up the surface of Mars, if only a bit. People still have to wear spacesuits when they go outside. It will take many more years until people will be able to breathe on Mars like they do on Earth. Gradually, rivers and lakes will appear. Green plants will cover most of the land. And then the inhabitants of Mars will be able to go outside without an oxygen helmet and call the red planet, now green, their home.